Welcome back. In the previous session, we have understood what is data. Now, in this session, let's try and understand why data warehouse is implemented in the first place. Well, to understand that, we need to know the basic terms or terminologies like enterprise, ODS, and DSS. Now, what is an enterprise? An enterprise, well, you can also call it as a firm or an organization, is nothing but an integration or combination of various departments which are working together for the business, right? For example, if you take IBM has multiple groups within the firm, right? Like IT, security, finance, logistics, HR, and many more. Now, all of these departments have to work on different things, but these are all under the same umbrella of something called as an IBM enterprise, right? For that matter, any company. Now we need to store all these data of multiple transactions and keep it in a particular location for others to use it. For example, let's say the finance team has to work on the payrolling for this month, right? Now it needs to get the information from HR on how many are the new joinees in the company for this month, right? And what is the package which was decided for them. And it also need to get the details from employees on what is the bank accounts they have and where should the salary be deposited and things like that, right? Now, if you've noticed, none of these happen in a single place. Your HR has how much amount you should be given, right? How much is your pay? And you have updated your details on your personal, for example, PeopleSoft software or any of the employee-based software within the company about your bank details, right? Now, finance has to consider both of these details to process your payroll, isn't it? Now, if you consider these things, for HR, there is a transaction. For PeopleSoft database, it's a transaction, and for finance it is also a transaction. Now all of these transactions, all of these requests and getting the query back with the result is earlier stored, or even now in some of the organizations stored in a place called ODS. That is nothing but a operational data store. Now the main characteristic of ODS is the data is not permanent, it is volatile. What does that mean? Volatile means data is changed randomly or it just vanishes, right? Volatility is a chemical terminology where it just turns all the liquid state turns into a air state or a fog state. So what is the issue here? It does not have any historical information, right? To keep the historical data, it is not possible for us to sustain with operational data store or ODS. That is one of the reasons why data warehouse is implemented, right? Now, data warehouse is also called as DSS, which is nothing but decision support system, because we use data warehouse to make decisions by understanding the data which is present in the data warehouse from multiple branches within the enterprise, and as it also stores the historical data, it would give you, or it would give the business more options to analyze the data in depth and come up with patterns, formats, forecasts, or what has happened to a particular situation, what would the company or what would the enterprise had done better to avoid that, or what would have been a better step to increase more profits and things like that, right? So that's the reason why we need a data warehouse implemented in the first place. We'll understand what a data mart is. A data mart is defined as an implementation of a data warehouse with a small and more tightly restricted scope of data and data warehouse functions which are serving a single department or a part of an organization. That means it is a subset of a complete data warehouse. In this case, let's say IBM as an organization has multiple departments within it, right? Like HR, logistics, finance, payroll, transportation, security. So all of these branches or all of these departments can have their own relational database to manage their data. For example, if you take security, their internal database for security can have all the information which holds the names of the security guards and the gate numbers and the timings which they work and what are the incidents which have happened at what gate and things like that. And if you take payroll, in the payroll you'll have total number of employees, what is the payout time, what is the rate card, what is the attendance, and all this information, right? So these are all individual databases within the organization, right? As a whole, if you look at it, we would need a complete data warehouse to manage all of this, but these are all the single departments which are part of an organization, right? Now let's see what are the different components of a data warehouse architecture. Now we have covered them briefly. Now let's go into the detail here. We can also call this as a generic architecture for a data warehouse, which can be taken as a baseline, and based on the business and the functional requirements, you can enhance it the way you want it or the way the project expects it. Right, first is the sources. Yes, we know that because it comes from different sources like operational systems, flat files, relational databases, etc., etc. And then you have the ETL tool, which is your transform or the data preparation method. You will also have the data warehouse maintenance and administration tools. Obviously, data modeling tools are required to interface with the external data models. And end of it, the data warehouse database on which all of these data is centralized, and the business intelligence, which is the end user data access, and the analysis tools, which is nothing but your reporting tools, right? So that's the overall picture. It is a little old. I'm sure you would find a better picture if you search for it in Google, but this makes more sense and it covers most of the aspects. That's why it's still there. And that is why we are still using it, right? So let's look at each of the components. So you have the sources here, which can be your operational systems, which is OLTP, flat files, relational, any of that. And then you have data cleansing tools and the ETL. Now, these both can be combined together. You can either use them separately as a data quality tool, like the Informatica data quality, Trillium, or IBM's data quality tool, with combination of ETL, which is your data stage or Power Center, Informatica Power Center, Ab initio, Pentaho, Talent, any of those which are present in the market, right? Now you have something called as local metadata here. Whenever you're using these data cleansing tools or ETL tools, you need to have that local metadata which you consider as a base for your rest of the design and data processing, right? So now, if you look at this box here, you have data modeling tools. Now, data modeling tools come into picture once you have the logical data model, which is nothing but your LDM. And once the logical model is created, for physical data model to be created, you'd use the data modeling tools like Irwin, Power Designer, and a couple of other tools which are available in the market, right? So whenever you convert the logical data model into the physical data model, and along with that, you define the local metadata as well, right? So as you notice, that data modeling tool is also being driven to your central warehouse, which is also connecting to your central metadata, and the data is coming from your ETL tools, right? So once the data is available in the centralized warehouse, you give the access to multiple systems, which is nothing but your business intelligence or any third-party systems. All right. Now, if you clearly define it, right, if you clearly split it into a way, all you have here is a data source, centralized warehouse,
and the reporting, right? So multiple tools come into picture here, which is your data quality tool, ETL tool, data modeling tool, and then your business intelligence tools, right? So these are the different basic components which are required for your data warehouse architecture.